Just find the right place in the program, make the appropriate change, and we'll run the whole thing again.
Speech is still very complicated. Music is simpler.
Is that a question?
Yes.
The question is futile.
My interpretation of the data leaves little room for error. The art of leadership is delegation.
That information is not available. This constitutes all available data.
You know what they say. No good deed goes unpunished.
Howdy, howdy. How's it going? Welcome to the sort of last part of this, last part of the build, sort of, apart from adding the antennas and building the discs, milling them out and fastening stuff. So yeah, last part of the design for the build. Okay, so what should we do first? So we'll just go over an overview. So a couple of the streams today, we've put the wing nuts on and the eyelet there. Did that the other day, made this balun, copy of this real world balun to add to the actual item. So we've got to concentrate on now. The only things left is the discs. Milling out the discs and adding the feed point anchors to it. Okay, let's just make sure we got some audio. What is going on? Hang on. To add to, yeah, we've got audio. It's alright. It's a bit crazy today. Anyway, so let's have a look. Just go over to the model a minute. So we've got this model which we've created, and what I've done so far, I've made this bit, these two discs, and these other two, they're all the same. We've modelled this so we can fit it in somewhere. So the idea is to slowly catch a monkey, basically add the whips to this plate. I'm going to fix them to the plate and get them swarred in and whatever they call it these days. And I will add more as we go, you know, more as we go. So far I've got two Amipro 40s. Right, so anyway, let's show you. I've today, this afternoon, about an hour ago, the brass inserts arrived and the bolts. So I've gone ahead and melted the brass inserts into this. It just so happens that these are white now, so I suppose I should make them white plastic really. But we'll sort that out after. So I've got to get the tube in. Have a look at this anyway. Here we go, ready? Have a look at the actual thing. Here it is. So I've gone ahead and bolted, put the brass inserts into there, melted them in. Two there, two there, two there, two there. Put these fixings, furniture fixings, they call them M6 by 18mm, which is enough to go through the two 6mm. I think they were 6mm. Yeah, 6mm each, which will give you 6mm into the brass melted in inserts. Anyway, so we've got, it's quite sturdy, well, very sturdy actually, but it's made of ABS, so it will give a bit. So if you've got a bit of wind, you can't really see it on camera very good, but it does, yeah, it does give. And it doesn't break, it's very pliable. So the disc will be mounted in the groove there. See that groove there? So when you assemble it, these two parts are separate. Like that, you can see the gap. Anyway, the disc will sandwich inside there for the upper radials, and the other one down there for the just like the drawing really. And put the 50mm. I'm going to try 50mm 3 by OD 3mm thick plastic pipe through the hole there like that. You mount it off, and you'll be able to rotate it. So you can have a vertical antenna, and you can rotate it for horizontal. And it'll be mounted in such a way off here that you'll be able to move it around. It's not so good in the horizontal way, but when you're that way up and you can move it around, it'll be like scanning, a bit like on one of these Navy ships where they've got this great big radar array that scans around. Anyway, and as well as all that, you can rotate the discs. So the antennas will be mounted on the discs, and you'll be able to rotate them that way and this way. So anyway, that is the idea. So today what we're going to do is make the discs. That's all we've got to do, make the discs. So anyway, I'll put that somewhere for now. Let's get on with making the discs. Why not? Here we go. Right, so the discs are already there, and they've got the holes in. Now they're not the right colour, I don't think. Did I colour them anything? No, I didn't colour them. So let's colour them. Let's try. Hang on. There's the actual disc. So it'll be an aluminium colour. Let's go on a lighter colour. Anodised aluminium. Yeah, you could go for that. Anyway, we've got the antenna holes in there, but what we haven't got the feed point mounting holes. And I also wanted to try and attach that's gone and done both, that's it. I wanted to try and work out how we can attach this. Because obviously it can't just float in free space like it is there. So what we're going to do, I think, I'm going to see if I can bring that up to there. So drill a hole there, mount it somewhere, and you pass the whole thing up. Now what we might have to do is put a spacer, a couple of nuts as a spacer, and that'll go up through there. It'll fasten it on, and as long as we've got a bit of movement on it, which we'll have a bit of movement, and I could, if you want, put an array of fixing holes. So once you can twist it as well, but you know, so you might want your. We've got our 4 metre dipole in the middle there. That's where ChatGPT has told me to put it. And then we've got our 6 metre one, which is there. That's the 6 metre one there. And then they go around. I've got a picture somewhere. So the idea is to mount the ones I've got first, get it all sward in and get some use out of it. They're quite long, that's the problem. I've scaled these down just so you can see a difference between them, but they're going to go off the page probably. And then we've got to also work out the mechanism here of holding it against the other one, because I want to be able to rotate this. Ideally I want to rotate it from the back here, so we can rotate it. So if I grab, yes, if I was to grab all of that there and to rotate it, did this the other day. Well, let's just go on the red. So we're going to rotate it like this. So the idea is you can rotate the whole array, and once you've once you've rotated it that way, or you could have it on an angle if you want. The idea is the whole thing will rotate as well, like that. So you've got a direction, sort of directional, or off the side of the antenna. Yeah, so off the side of the antenna. Could do with modelling the whips really as well, and the end. I suppose we could just copy that and modify that end onto the end of there and put the steel whips on. But like I said, this was just a representation of where they were going to go. But in reality, most of them will be the same. The steel whips will be slightly different. So now I thought about a drive belt on here, creating a 3D printed thing that will fit over, that can be welded on somehow, 2-pack welded on, and a drive belt that can be powered, and it'll turn the whole thing. So I don't know if it can do this. Hang on, yeah, it probably can do this. So if I just do it from the back here like this, so we basically the drive belt allows you to move the whole thing around like this. So you know, you might want to bounce off a cloud or something, or just experiment, see if altering this gets you a better signal. Basically tune it like a mag loop. Just try to tune your signal in a bit better, you know. Whatever. Don't know if it'll make much difference on HF. It's weird stuff, isn't it, HF? But anyway, let's just do some undo rotating. Let's get back around to it. So all we need to do is create the G code, but I've got to, like I say, I've got to work out where this is going to go now. I can either drill a series of holes around it, take longer to mill then. Take longer to mill, but I mean, if the water builds up, it will drip around it. So yeah, it might be worth drilling some extra holes anyway. Just going to take longer. Every hole you drill is going to take longer to mill the plate. So the idea is the bottom one will spin. They both will spin, but the bottom one, we can tether make this fit the. Excuse me, I'm going to sneeze. Hang on. So I'm all flued up, but anyway, right. Yeah, so I suppose really this should be in the middle, but I don't think it'll matter that much. If I fasten that, it's got to be fastened to the plate. And then we'll have a flying lead off. We can either fasten this to the bottom plate, which will restrict our movement, or because we want to rotate the bottom plate, because it's supposed to be slightly offset from the top, according a little bit. So anyway, so I'll tell you what, we'll have a series of holes on here, so we can undo the driven element. So basically, what we need to do is make sure this is spaced. If I can look at it from above in parallel projection. Right, and then in X-ray, you can find out where this piece is. So it's not quite centered, you can see it, but it is offset. This hole is offset to the rest, so yeah, we're going to have to allow for that. And you've got to get your connection on your coax, so yeah, we need to move the whole thing over, at least center it. Let's try and center it. So I'm going to grab that, and I'm going to look back up like that. This is all how it should be now. So I'm going to grab it. I'm going to go just left with it. Try and centre that up. Is that about it? It's about there, isn't it? Yeah, it doesn't give us too much. It's okay there, but it doesn't give us much movement. Well, that's okay. Maybe we don't need the movement, so we could afford to go a little bit up. So if we put it there where it is now, and then we grab it again and then go up, just in a bit like that. That's what it, now you can see why we had to model it. Okay, I'm going to fasten it there like that. Oh, have I just copied it? Did I copy it? Undo set insertion point, undo move, undo close. Oh, have I got two? I know what it is, I've still got the two. Redo move, redo set insertion point. Yeah, I've still got the old one on here. I think. No, I've just got some extra. I know what I did. I deleted the old one but didn't delete the nuts. Yeah, that's right. So we're in the right place now. Okay, so go back to that. So what I've got to do is get a copy of that hole and mount it here, and then rotate it. Give ourselves the option to put it either side. Something doesn't look right there, does it? That hole is there, offset to that one. Why is that? Surely that would be centred, wouldn't it? Right, I need to bring in the drawing. Hold on a second. Right, I'm going to bring the drawing in. Import. Right, this drawing again. Yeah. So there's something wrong with my drawing, isn't there? Surely. So I'll put that there. Let's try and make it the same size, roughly. Yeah, my spacing's wrong, isn't it? It's weird, isn't it? The whole thing shifted a bit. The disc's right, but because I'm sure that. Oh, hang on. No. So why has he done it this way? ChatGPT created the space in here. No. See, if I measure from there to there, 33 mil. If I go from there to there, I've got 18 mil. So it's right. So I'm not quite sure why it's not evenly spaced. I've told it to space them where they need to be, so I suppose it had to be a certain distance from the others. So that's a bit weird. Well, it was done electrically, I suppose. Unless that's a mistake on their part. Right. I could go back to ChatGPT and ask it the question, because I need that. You'd think that would be spaced out correctly, but then they didn't put that one in the middle either. No, we'll leave it like that. It will be a bit weird. Yeah, we'll leave it like that. Don't know why they've done it like that. Must have been a reason for it. We'd think it'd space them out. I mean, it should be centred on the disc, surely. So, let me see. I think we need to space it up. Yeah, because that needs to be... If they're all spaced apart the same distance, if I don't move them, they'll be fine, but it's not actually centred. I don't know why they didn't centre it. Oh, that's not centred to that either. See that? This is the one ChatGPT made me. It's 20 metres, slightly in compared to that one. And that, come to think of it, that's not even... Oh, it is. Right, so if I go that from there down, see it's offset. If I go from there down, that one's offset as well. So I think it's designed it this way. It's got to be this way, right? Or has it just done a very bad job of it? I'd have to ask it, I suppose. I don't know why it's done that. Anyway, we'll just go with it. It will fit in there. We'll go with it. Apart from, now is it including the disc size as well? I would have to ask it. Let's go and ask it. I can bring back the chat on it.
London Rhino 169 Charlie Direct, Pepe, climbing to level 190, good evening.
Can you look back at previous
Route direct CSP and request flight level 350, Rhino 169 Charlie. Rhino 169 Charlie, keep climbing initially, flight level 2.
I can't see any use contact.
Flight level 270, Rhino 169 Charlie.
Right, you made me a... Hang on, let's get this over here so you can see what's going on. You made me a disc for a vertical fan dipole about to create the G code and found the spacing is not equal. Was this intentional? Intentional. Right, let's see if it can find that. Yeah, it was assuming that this is the fan dipole disc we designed to manage multiple dipole legs of different lengths on a single vertical support. Here's why the spacing was not equal. It was unequal spacing intentional. In a fan dipole, equal angular spacing is not electrically optimal. Unequal space is commonly used for reduce inner element coupling. Elements that are closer in resonant frequency are spaced farther apart to minimise mutual detuning, improve impedance stability. Strategic spacing helps keep the feed point impedance reasonable across the bands, instead of one band badly pulling to another. Control current interaction. Longer, lower frequency elements interact more strongly, so they're often given more room. So the disc spacing was likely wider between two band elements, tighter between higher frequency elements, not mechanically set but electrically intentional. Before you create, double check, confirm the angular positions. Can I upload your diagram. Yes, go ahead. Right, okay. Right, I'm going to add this diagram. Add a photo or file. Downloads. PNG, is that the same one? No. Yes, thanks for uploading it. I've looked closely at the diagram. I can confirm the unequal angle space is intentional and correct for what the disk is doing. Let me walk you through it clearly. What the diagram shows, sanity check, disk diameter 200 mm, center mast hole 9.5 millimeter, 6 fan dipole attachment holes. This doesn't show the 4 meter. This is a vertical, not a symmetrical radial plate. Why the spacing isn't even by design. Bands close, yeah, it's told me that. Important mechanical electrical details, da-da-da. Generate your final check. Make sure all hole radial distances from centre are identical. Radial distances from centre, yeah. Angular positions are exact. You do not mirror optimize spacing. If you want to connect, extract exact angles for each band. Help you generate XY coordinates. Not necessary.
662, descend to flight level 180, be level by Zurich. 180, level by Zurich.
I have recreated 5mm round plates and have them in SketchUp file. SketchUp design, and the antennas are closer to the bottom edge than the top. Good catch, and yes, that is expected with the way the plate was laid out, but there's also an important limit check to do before you cut anything. Let's separate what's intentional and what might need correcting. Why they appear closer to the bottom edge? In the original concept, the centre mast hole is not visible, visually centred in the drawings shaded. The fan holes are placed on a fixed bolt circle, not centred top to bottom in the disc visually. Because 40 metre is allowed at the top and 6 metre is allowed at the bottom, your eye is drawn downwards, so in SketchUp it looks like everything is close to the bottom edge, even when the geometry is actually correct. The real test, this might ignore how it looks and check numbers. All the antenna holes the same radius from the centre are all now. Measure 1, distance from the centre hole centre. They must all be identical. 70 to 80mm depending on design. If yes, the design is correct. Are the edge clearances acceptable for a 5mm thick plate? Rule of thumb. Right, when this would be wrong, you should adjust the design if the bolt's circle radius is so large that the 6mm is within 10mm of the edge, or the 40mm hole has much more edge margin. Right, why didn't, I'm getting weird, why we didn't centre them vertically. Centering the bolt holes vertically would push. In SketchUp, measure centre hole radius, measure edge clearance. Tell me, right. Are you able to examine a SketchUp file? Yes, I can examine a SketchUp, but there's just a couple of practical deals. So what I can do, if you look at the SketchUp file, expect hole position, check center, right, okay. Okay, let's just try and do that then. So we'll give him this plate.
Turn left at 280 degree. We go to 183, turn left at
Export.
Left at 280 degrees,
I'll give him an STL. Oops. Hang on, what happened? STL. Right. I will upload STL of the plate. Right.
Nordic 1 Delta Yankee London. Good evening. Direct to Knocking, November Oscar Kilo India November.
Oh God, is it finished?
Direct to Knocking, Nordic 1 Delta.
What's it done now? New chat, don't want none of that. Oh, right, I've run out of thing. Seems I have run out of free time. Ah, why didn't you let me do that? Little bastard.
As they're on 10, right, you will be a level restriction before lift goes. Copy, thanks, 740.
Oh, won't even let me enter that in. That's the trouble. Right. I've got to wait an hour. That's no good, is it?
183, climb flight level 340.
Right. Anyway, I think as long as we maintain the distances apart. So what I'm going to do is I'm purposely going to shift them, keep them all the same, but shift them. So what I need to do is work out. Let's do a circle. Let's do a circle.
Ryanair 406, thank you. Direct to Fancy.
So I'll do a circle. Let's have a look where it goes to. So definitely wrong. Look. So what I'll do is try to shift them. Well, yeah, he's offset it. So I'm going to keep them where they are, but just shift them up a bit. Right. Where though?
London, Shamrock 687, flight level 360, directed back decimal 7. Shamrock 687.
So I've got it there, so yeah, that's a circle.
Shamrock 687.
So if I do a circle like that, temporary circle, and then if I go into this,
183, direct to
view the rest of the model in, we're in X-ray. Ah. Hide the rest. Hide similar components. Hide the rest of the model. Right, where's my thing gone?
Right. We're going to go in on the Badsy Lipko route. So we're now blending for Lima arrival. Badsy, let's go in at the Alvin for Lima.
Why can't I see it?
Shamrock 67. Shamrock 637 in back. This is 10
I'm in
right.
X-ray. Why can't I see the?
Thanks for that, Shamrock 67.
It's too far gone, isn't it? Okay. Let's put one on top of there then. Don't know what's going on. There we go. So we're going to this. I'm going to select all the nuts. No, that's not selected all the nuts. Why not? Hang on. Let's turn off the lower one. Turn off the lower. Right, so we're going to select this one.
Ryanair 53 Hotel Foxtrot, climb with level 270, Colonel request 370.
Right.
Ryanair 23 Hotel Foxtrot.
Right, doesn't look like it's selected. I'm going to move these up.
Ryanair 53 Hotel Foxtrot.
No. What? What's going on? That's weird. Why can't I select everything I want to select? Right, I've got to select manually, have I? It's the holes I want, isn't it?
London Shamrock 687, can you confirm the landing runway in Dublin?
Right, so maybe I'm not,
Shamrock 687,
not actually selected the disc.
10 right, thanks for that, Shamrock 687.
Now I have, so if I select that disc now, everything, and move, that's it, I can move the holes up, just tell it which way I want to go.
And London Seabird 183. Seabird 183.
No.
We just amend our requested cruising level to level 360, please. Seabird 183.
Right, what's going on? So I've got the holes, I need to set it. Hang on, which way am I going? Green, that's why.
Ryanair 24 Hotel Golf, expect flight level 180 at Fan B. When you're ready, descend to flight level 1.
Why is it doing that? No, that's not right.
Expect flight level 180 at Fan B. When ready, descend flight level 200 Ryanair 24 Hotel Golf.
So I want to move the holes up, but keep.
London, good evening, Atlanta 774 heavy, flight level 320 eastbound Oxford.
Hang on, which way is it?
Atlanta 7746, direct to Atari.
Is that right? No. No, that's the other way.
London, France 026,
No.
good evening, flight level 360. France 026, London, roger.
No, that's wrong. Okay, let's try another way. Perspective.
Ryanair 53 Hotel Foxtrot, climb flight level 350.
Flight level 350, Ryanair 53 Hotel Foxtrot.
The arrow's in the way. So here's the green. But it won't let me, once I selected green, it won't let me go the way I want. Now it will. Right, hang on. Let's have a look above. Come out of that one. So we're down here. Oh, I need to be centered there somehow. It's not quite centered. What a crock. It's calculated these. Do I go with what it says, or should I put them where I want them? I have to go with what it says, otherwise.
You can route now direct to Badsy.
Right, is that better? It's still random, isn't it? Is that better? It's just sort of better, yeah. Let's do that. Right, so we put them there. I've got to select the antennas now. The antennas. And I've got to move them. That looks right. Yeah, that went okay. So is that's a bit better now, they're all spaced.
London, good evening, runner 5000, can I have 210?
Well, they're okay here, but they're not quite spaced right there. It's better, but the problem I got is I've got to, yeah, I can get to all the bolts, so it doesn't really matter where they are. Yeah, I'm not sure. Let's have a look.
Good evening, airline 79 Bravo, climbing flight level 170 towards.
So there's a lot more between that one and that one. Why do they are at random?
Direct taxi, airline 79 Bravo.
Does it matter? It must matter somehow.
9024 Hotel Golf.
Right, we'll leave it at that, I think.
Flight level 180, level by Fancy, Ryanair 24 Hotel Golf.
Seems like it wants to go over a touch, but that is lined up with that one. Now we'll leave it like that. Okay, we're going to leave it like that. So I've got it a bit better centered for when I spin it round, and it's still adhering to the layout. Right, so I need to get rid of that and that and that.
When you're ready, descend to flight level 200.
Okay, and I need to reproduce that plate twice now. So we want the bottom one.
9.79 and on to the.
Oh, have I changed the bottom one now? Yeah, it was the same plate, wasn't it? Yeah. So it's just the aerials I've got to move to match it. Yeah, so I did do it right. Well, yeah. I've just got to move these now to match the new template, because the template, the same plate was the top and bottom. So I've got to literally.
Chumbox 687, you happy with the routing now?
No.
Yeah, we're happy with the routing, Chumbox 687.
No. That one. No.
London Airline 79 Bravo, edge from
No.
flight level
So it is that one.
Airline 79 Bravo, A-firm, stop climb flight level 160. Stop climb flight level 160.
Right, is that okay? Something's not right. Don't know what though. Is it okay? Yeah, it's okay.
Ryanair 4003, when you're ready, descend to flight level 200 and be level 10 miles before Liverpool.
Right, I think it's okay.
Ready, descend to 200 at the level 10 miles before Liverpool.
Right, so let's get rid of that one again.
X-ray 79.
Pull that off, X-ray. Yeah, so we're where we want them now. Yeah, they're much better spaced out, so that's alright. They're equal. So what we've got to do now is put that hole up there. Now there's more space this side, isn't there?
1824 Hotel Golf, contact Cardiff 125.
Doesn't matter.
125,
It needs to be nearer the higher band, 6 and 4 megahertz. Meters, sorry, 6 and 4 meters. So yeah, we'll keep that close to that. Right, let's look at it again. Put it in this one. Go in X-ray and zoom up to it like this. And are we still okay? Yeah, we're still okay for that. So what I need to do now is grab...
If you just monitor that rate of climb, you've got company traffic in your hop us 1,000 feet above.
Grab the top of the balloon, the wing. So I want that copy there, probably that one. 6mm, so we'll copy that. And we'll paste it in place, then we've got to bring it up. Bring it up.
687, it says 0.77 and non-conversion 280.
We're going to go right up to get away from these aerials so it'll snap to the blue.
And 280 on conversion over Shamrock 67.
So we go with the blue, we'll bring it down to there. Right, it should be there now, and all I've got to do is land it down. Drop that down to the deck there. Make sure we're only going to go in the down direction. And it's done it for me to put it where we want it. Now I've got to cut that. And paste it in place. Right, and I think I've made it 5mm thick. So 5mm.
Atlanta 7746, turn right 10 degrees.
Let's just make sure that is 6mm, because you need... It's 5mm. Yeah, the wing nut is 5mm. But it's actually 4.6 something, the thread, so it should still fit in there. Okay, so if we look at it from above, in parallel projection, we should be able to then see, and also X-ray. Yeah, it lines up perfectly, look. That's good. So that's got a mounting hole. Right, so that's going to stay there where it is. And let's make sure we've got enough room for coax to appear. Enough room for the coax to be plugged in. It's tight fit there, isn't it? Is that tight fit? Might be. You can also use an elbow. Might just have enough clearance there. Let's have a look. It's tight. It's a tight fit, so we might have to drop that over a bit to allow for that. That's okay, we've got a space here, so we can afford to come over a bit. Why am I in black and white? Shady with textures. Oh, I see. Right, so what I need to do now is move this over just enough. Just enough. What's it done?
Atlanta 7746, turn left heading 30.
Right, I'll go 10mm at a time. So it's just touching that there at 10mm. That's okay, it could probably be wound down a bit. And I've got enough space now there.
What's the lay looking like?
We've got 29 Golf, 2 minutes for you.
Yeah, so, right, let's come back.
29 Golf back.
Come back 3mm. Is that too much? It's just touching, isn't it? Could always take that off, but I'd rather leave it on. Right, let's come back another 1mm. Right, that's it. So yeah, we're okay there. We've got the maximum space for the fitting. Okay, I think we should be able to live with that. So in effect, I've moved it over 6mm, I think. Alright, let's just move that over 6mm. Right, let's come out of it and have a look at it and make sure we're still lined up. Let's have a look. Yeah, we're still lined up. Oh, we're not. We're slightly out. Why are we slightly out? What's that distance between there and there? That is weird, isn't it? Don't get that. I was sure that was a perfect fit earlier. It's not quite. Oh, maybe the hole is, maybe the wing nut isn't. Weird.
Logan 841, Roger, flying flight level 150.
I thought I was spot on. Yeah, I thought I was spot on. Right, so I'm spot on, but something's not quite right. That's weird. Right, tell you what, let's do some undoing. Undo, 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 undo. Right, so they should all be lined up again now.
Ryanair 400 X-ray.
Ryanair 400
Yep, I'm just checking what part of my speed restrictions did you comply with? You're given 7...
Oh, we're out there anyway, look.
Knots. I've never seen once that you've done either of those.
Why were we out? Shouldn't have been out at all.
79 all the way across. It's just slowed down below 280 knots. You've got 55 knots out.
Alright, let's
Well, the
just
camera behind you is doing exactly as I asked it. And,
put this balun in a separate place.
280 knots.
New layer.
Dublin 135.655. I've had to stop him off because of your
Balun.
35655. We can go fast and straight knots if you like.
Turn off the balun.
Yeah, you'll catch the other one in front of you. Here's the reason why we do it.
Right, so let's try and find out which is wrong.
Ryanair 602 Echo, request 10 please.
Ryanair 602 Echo, descend to flight level 200 and level 10 miles before Limco.
And order level 10 before Limco, Ryanair 602 Echo. Good evening, Gen X44, Charlie, Solid for 380, Great Nelson.
Right, it's yeah, it's the hole slightly out.
Pepsi for a Pepsi 1 Lima.
Okay.
Pepsi 1 Lima, Gen X44, Charlie.
Let's make the hole not slightly out then.
Shamrock 687, you able to come back to 250 knots?
Yes, I'm Shamrock 687.
Shamrock 687, descend to flight level 210.
Yes, that was 210, Shamrock 687.
What's going on? It's not snapping.
841, climb flight level 270.
Why is it not snapping at all?
London, good evening from Morocco, India, landing 190, passing 160.
Right, let's just get rid of the holes a minute.
India, good evening, climb flight level 280. What's your
Right, the problem is I'm not quite lined up.
360.
Okay, this direction 350.
Right, so take off the top a minute.
370, requesting
Upper section.
India. Roger. Come up 687, descend to flight level 200.
Right, upper section is gone. It's my lining up that's not good. Anyway, that's beside the point at the minute. Yeah, my lining up wasn't good, but the pin's good. As long as I copy the pin. Right, so maybe my lining was okay. Right, so hide the balun. Let's just have a look. Balun on. It'll be fine. It'll be fine. Right, so we've got the hole. Right, that's good. Put the lower section. Oh, the balun. Right, so we've got choice there. Okay, we're alright. Yeah, that'll do. So do we want the ability to mount anything else to it? Probably could do with a cable tie hole or something. But yeah, could probably do with a couple of holes for fastening stuff. Maybe a 10-turn coil choke this side.
Turkish 1-1, London, good evening, direct to Mallet.
But if it's tied to there, you won't be able to turn it anyway. Alright, we'll leave it at that for now. We can always drill an extra hole if we need it. Right, let's come out of X-ray mode. Right, let's get these G codes done for this then. So I need to find a million bit that'll fit. Oh, that needs to go up, doesn't it? Right, so we need to put that ballon where it's going to go. Let's say it wants to go... No, that's the wrong way around. Let's just go there like that. And...
Line 79 Bravo, contact Cardiff 125.855. 125.855.
So spring washer, it doesn't matter which way it goes. We'll leave it like that for now. Let's stick the whole thing up. Let's go up until we can see it. Drop the whole thing down till it touches the top of there. Okay. So we can just see there's not enough room for a nut there. We need to put the nuts in. There might be just enough room for the nut. Yeah, so it'll be a bit tight for the nut on that one. That's the 4 metre one. Oh, no, it's the 6 metre one, sorry. 6 metre one. So we really ought to model the nut next. Make sure they're not going to be in each other's way. Let's do the nut. Let's model a nut. Ready? We've got the nuts here, the stainless steel 3/8 by 24, is it? Nuts. Alright, let's model a nut to go on the end of that. Let's just do one here, why not? Right, here we go. That's hex nut. So we need to measure it. I think we measure the diameter. Right, 15 mil. Well, yeah, 15 mil will give us enough clearance. So half of 15, 7.5. And the width, or the depth of it. Depth of it is 8 mil. Excuse me. 8 mil. And we've got a bevel. What's that bevel? Let's say it's
London Sender, good evening Turkish, 29 Mike,
it's more of a circle.
Turkish 29 Mike, London, direct to
It's more of a circle, isn't it?
Direct to Lipko, Turkish, 29 Mike.
I don't know if I can do a circle or not. Let's try it. Is that okay? Yeah, that might be okay. Can I select this edge and then bring it down? I might be able to. It needs to go down like at least 1.5 mil, 1 mil. What's that? That's 1 mil. Is that enough? Yeah, 1 mil. The hole in the centre is 8.25.
X 3 kilo Mike, you can turn left now to Pomax.
Pomax, thank you, 3 kilo Mike.
So 4.125. go all the way through to the bottom. And we've got a bit of a, yeah, offset. Looks like another, looks like definitely a mill. No, let's not go a mill, let's go 0.75. I'll drop that bit down by the same amount, let's say a mil. Right, so we've got that knot. Problem is, we need to do the same. Create it into a. Make sure we haven't selected anything. Make a component. Let's lift it up a minute. Bring it out here. Right, we need to do the same underneath it as we've just done on top. So we want a circle. I suppose that's okay. Intersect the face with the model. Get rid of that. Don't need the extra surface, so we need to grab hold of. Oh, that should be. Paste in place. Need to grab that and move it down. 1 mil. Right, what's happened? No, it's not gone right, has it? Right, something gone wrong there. Let's get that down. 1 mil. Okay. Want that gone. What's happened to there? Inside. No. Do it raise.
Just got up flight level 450.
November 974 Hotel Romeo, thank you. Direct to Annette.
Direct Annette 4 Hotel Romeo.
Oh, shit, what we got now? Oh. That's okay, it's back okay again. Right, so almost there, apart from the little bevel. 0.75 and 1 mil. Right, so we've got ourselves a nut. Right, so we've got ourselves a nut. Let's see if we can move it. Right, that's the nut we need, so we don't get stuck when we come to assemble it, like that one there. We need to make sure that nut will go on. We'll need X-ray mode for this. Right, let's get that on the thread here.
Easy 319 whiskey, climb flight level 300.
Flight level 300, easy 319 whiskey.
Let's come out of X-ray mode now. What's happened to the, where's the face of the nut gone? What's that, a glitch? What's happened to the face?
2565, turning 3 kilo Max.
What have I done? That's weird. Right, don't know what I did. Must have deleted by accident. Anyway, so we're back on. You can see it's touching the balun at the minute, but it's got to sit down. So let's get it down to the deck. Let's just make sure we're only going down. Alright. Now the question is, will it clear? Yes, it will. And you've got enough clearance for a washer if you want it. Just about got the clearance. That's okay. That's all we wanted to know. Problem is, we haven't painted it.
Bluebird 29 Golf, and navigation back to Zurich.
Zurich, 29 Golf.
Royal Emirate 819 India, and navigation Salco.
Call navigation on 819 India.
EG 319 Whiskey, climb flight level 320.
Climb flight level 320, EG 319 Whiskey.
Okay, we're now painted, so we're okay. So we've got our nut, and we need more nuts all the way around. Really. Can I be bothered to do all those nuts? Not really, because the rest I haven't got no clearance. I'll do them later. Do them later. So these are okay, they're not in the way of nothing. It's just that one I need to make sure it's physically able to do what we want to do. That'll have to have an extra nut on it there, probably. Although it can go down a bit more, that can, and sit in that well. If it wants. Yeah. I think we're alright now, so let's just bring it back to the scrape. So, the question we got now is, can we mill out the plates? Keeps wanting to go that way. Right. So we've got to be able to mill these plates out, so let's save it. So the problem is we need to know the G code. We need to know the size of the milling bit. Now I've got various size milling bits. What was the last thing I milled out that was a disc? Just going back a bit. So, yeah, that's the only problem. I've got to make sure I've got the right size milling bit. I suppose I ought to go and check it. Right, I'll tell you what I'll do. Give me 5, I'll go and find the milling bit. Unless I got some here. Let me just see if I got some here. Let's see if we got some milling bits here.
Contact London 135.
That's what I could do with actually a 3D printed milling bit holder. That will help a lot. To hold all the milling bits. I feel the took them all down. No, I can't see any there. Must have took them down. Yeah. Right, give me a second. I'm going to go and find a milling bit. Back in a bit. Right, I'm back. I found a milling bit. Cutting tool. Right. I don't know where it came from. Let's have a look. I can get that in there. Does it say on it? 4.5. Is it a 4.5? Let's find out. Is it a 4.5? 2 flute end mill. Yeah. 4.5. Okay, so, and it's only so deep though. Doesn't like, hang on, is it 4.5 there? Yeah. 4.5 and it's only 13 mil, which is okay. They're only 5 mil deep anyway. Right, that'll do then. So I'm going to use a 4.5. That's all we need to know to create the G code. Right, so what we're going to do, go back into the model. Right, so what we're going to do is I'm going to open up. No, I haven't done any milling out for a while. What was the last thing I milled out? Brackets for the the laser. Tell you what, we'll just start again. What we'll do is we'll start again. We'll go into the settings. Just save what we've got so far. I'm going to go into the G code settings. This is the sketch UCAM. This is the bit that creates a G code. So the plunge rate, everything's default. Right, material thickness. I'm going to say it's 6 mil, but I think it's 5 mil. So I'm going to tell it it's 6.15. Right, and the bit is 4.5 millimeter. Safe travel will just make it 10 mil. Right, I've got an overhead gantry. Multiple pass because we're doing aluminium. How much per pass? Not a lot. Let's say 0.2 of a mil. Yeah, should be enough. We're not going to drill. We're not going to mill a mil at a time. 0.2 of a mil. So yeah, that's enough. 0.2 of a mil. Bit diameter set. Material is set. Feed rate needs to be a lot lower. Plunge rate definitely a lot lower. We're going to drop this down to feed rate. This needs to be a lot lower than that. Let's just make it 800. The spindle speed, I'm not going to have it that fast, so I'm going to say 8,000 will do. You can always alter it a bit. Plunge rate, yeah, everything else is good. Generator multiple pass, overhead gantry. Right, that's it. So we can save that. Okay, it's automatically put a safe area on it. Didn't really want that there, really. So we could leave it there, I suppose. So what I need to do now is get just this bit. Let's see if we can. I've never done it this way. Let's see if we can do it this way. Now I'll tell you what we'll do. We'll create a separate area, shall we? Or should we create a separate file? Tell you what, we'll do a save as. Save as, and we'll call it plate G code. Okay, so we're saving this plate G code. So we want to get just the plate. That's all we need. Copy that. Right, we'll look at it from above. in parallel projection. We'll paste it in place, or paste it.
Very good evening, North 1715, level 360
We want to do it, get the axes back. So we're going to go like this, 10 mil in, 10 mil in, and we're going to go 700, that's it. Right, so that's part of that, isn't it? Right, so we need to get that out of there, cut it and paste it, and paste it, put it over here. Right, we've got some marks on it now. Tell you what, let's get the meter, let's get that out of the way of there. Let's go all the way there. Well, actually, let's go somewhere where it's to a certain point. 1,400. There we go. We've got a known idea, so we can then we've got to copy this now, push it over to there and there. And then we want to make sure, no, we're slightly high. Where is it? Right, it's that line there, isn't it? So which one? Oh, we're high on that one. So we need to get the thing from that one. 1,400. Right, that's it. No, it's still high. Why is that high? That's weird.
London, Lima Delta 272.
Oh, we're low. We're low on the plate, that's why.
Lima Delta 272 London, direct to Leslie.
So we're going to put that to
Lima
there.
Delta 272, direct Leslie.
Easy 105 when you're ready, descend flight level 160, available by Wembley.
We need to get this bang on.
When ready, descend flight level 160, level by Wembley, easy 105.
Bang on it needs to be, so we don't have any problems. Oh, it's not going to work. That one will, this one won't. So we need a one from there. 10 mil over, that's it. And we need that plate to be lined up with that. No, it's not happening for us today. So let's try and get that lined up here. That's better. Got to get those lined up, otherwise you're going to go wrong. Right. Okay. So we need to split it now. So we'll make this unique, and we'll explode it. We'll look at it end on. In parallel projection. Just make sure we're looking at the right thing. Yeah, we are. End on. And we're going to get rid of the top bit. So we've just got the holes left now. This is what we're going to create the G code from. So that'll do for that. Okay. It's going to be a bit weird because it's got steps in it instead of circle, but never mind. Right, that's all we want. So what we're going to do now is we've got to take all the holes out of it, cut, Paste in place. No. Cut. Right, I'm going to have to make that group it to get these out, to cut them and paste them on top. Then we have to cut them again. Now we have to go in and paste them in place, and then we can explode it. Right, and this is so we can create the G code where we want it. So we've already told it the size of everything. Let's save that there. We've already told it we've got the 6.15. It's 5 mil, but I don't mind if we mill through a little bit. Just get it to get done.
Nordic 71 November, London.
Tell you what, let's change that. Let's make it 5 point. We'll meet them halfway. 5.5. Bit diameter's 4.5. Yeah, everything else is good. Plunge rate. Can we change the plunge rate? Planning to go a bit slower on the plunge rate. Feed rate. Everything else is okay. Right, so what we'll do now is we'll quickly save that, and now we've got to do we need to set our safe area, so let's measure for our safe area. So say 210 by say 220 220. Right, let's change that then. Safe area 220 220. Okay. Right, and we'll bring the safe area into here.
Thank you. Could you recall me, please? 133.6.
Oh, I won't be able to bring it there yet. What I need is a 10 mil off that one, and a 10 mil off that one, and then it'll allow me to bring the safe area, and it'll snap to that point there. Right, that's the safe area. Save that. So what we're going to do now is do the inside, try and do an inside cut on these holes. So that's the inside cut. Oh, we can do an inside cut.
London LRNS 644 Victor, climbing to level 280 Cardinal.
Right, now we need an outside cut. That's it, we're done. We are done. So tomorrow I can mill out those 2 plates. So let's create the G code. Let's output the G code. Let's call it right, so we're going to call it, that's it, G code. Right, save. It's going to create a G code. We'll go on online tool and we'll check the G code, see if it looks like it's about right for us. So let me open a browser. Here we go. NC Viewer it's called. Right, I'm going to open that file we've just created. Hang on, just get rid of this doxing rubbish. Right, open the file. Right, so we've just called it G code. That's it there, isn't it? 2024, that's the one. So I'm going to open that up, and this is our file that we've just created to cut out this plate. Okay, so let's give it a run, see what happens. So it's doing the hole. The hole's for the antenna.
551 Sierra November, plane level 400.
November 551 Sierra November, London, good evening, direct to Adara.
Direct Adara for 551 Sierra November, thanks.
Right, we've managed to do it pretty quick. We can speed that up a bit. Let's speed it up. You can see how many passes it's doing. Look, I've told it to do 0.2 of a mil, so it's got 1, 2. You can actually count them: 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 6, 27, 28. It's about 28 passes with that mill bit. 28 passes. So it'll do now, speed it up a bit. Is that speeding it up or is that the end? Yeah, speeds it up. Yeah, so we're speeding it up just to get it to go around and make sure there's no surprises in the G code. So it's doing the small one now. Let's go to the big one. So it's simulating the milling machine or the CNC software. You can actually watch it lowering down as it goes down and down and down and down and mills it out. That's pretty good. There's no anomalies. Just look out for anomalous stuff, funny things that you don't expect it to do. It looks good to me. We'll let it run through. We'll let it run through. And it'll be the big one at the end. It goes all the way around at the end.
Lima Delta 272, contact Shannon,
There you go.
15230, goodbye.
Okay.
135,
And you can see the code on the left running through. So it looks all good to me. So we'll leave it at that. Right, that is going to be it. So where's that gone? Oh, I only got the plate. Tell you what, let's get rid of this. Delete all that. So we've just got the G code on this one. Save it. Right, let's go back to the normal one. See if we haven't got an empty file. Right, so we're back on it. So we've got everything we need now to mill out this, to finish this bit off, apart from the pipe. Got to pick up some pipe. Now I was thinking of putting a plastic pipe and then maybe inserting in here a scaffold or galvanised pipe inside to give it some strength up till about here. Then we've got to work out how we're going to fasten it in and everything. Looks like a blooming bomb, doesn't it? Oh well. Right, so that's it. I'll give you a quick view of this thing in case you missed the live stream at the start. So today, what is an overview? What we've done today? We finished the design of the ballon, the ring, and the thumb turn or the wing nut, and the rest of it. I've put the brass inserts into here. They came today. M6 brass melting inserts. I've melted them in on 8 parts. So 1, 2, 3, 4, 5, 6, 7, 8. I've used these furniture fixing stainless steel with a wide flange. They've got the wide flange on them, and it screws straight through. It holds the 2 rings together, which in turn will clamp the new plate when I've milled it together. And the other bottom is on a separate plate, clamped again from the other side. It'll allow you to rotate the upper whips and the lower whips separately, and the plastic tube will allow it to rotate like this, so you can point your antennas wherever you want them. You can either have them horizontal, so they stick out here and there, or vertical, or even on a bend. So we'll be able to, once I've got the pipe on it, the intention is to melt, or not melt, glue the pipe in here, glue the plastic pipe, and the pipe's got to be strong enough to take the weight of it, so I might have to insert some steel inside the pipe if it appears too heavy. But we don't want no steel in here really. We don't want steel in this bit here. So we want plastic pipe up till about there, and then the steel just to support it and down. But yeah, the best way of doing it is to. Anyway, so we've got so far. That'll do for now. Let's just spin it. Okay, so we've turned a bit of drawing into this. It's quite big, but the antenna, the whips will sit on top of the plate. So tomorrow I'll make the 2 plates, and I'll put the 2 plates in here, and I'll mount the whips. Now we need the tube to be able to mount it to something to stop it, you know, to fix it to something. Could do some kind of a stand or something. Anyway, that's got to be it for today. Thanks for watching, and I'm out of here. Bye bye. I'm not really this red, it's the lighting. It's the lighting off that lamp. If I turn it off, still showing weirdness. Maybe I am that red. Right, anyway, that's it. I'm gone. Catch you maybe tomorrow, you never know. Bye for now. So I'll leave you with that. Let's get a thumbnail on it. Looks like a Christmas cake. Save it and go over to the thumbnail, and I'm out of here. Thanks for watching, and goodbye.
Just find the right place in the program, make the appropriate change, and we'll run the whole thing again.
Speech is still very complicated. Music is simpler. Is that a question?
Yes.
The question is futile.
My interpretation of the data leaves little room for error. The art of leadership is delegation.
That information is not available. This constitutes all available data.
You know what they say. No good deed goes unpunished.